Hello and welcome to ROS 101 Fun Approach, delivered to you by Samer. This is our second session. So first let's do a quick recap. Last time we talked about ROS, or Robot Operating System, and we said that the special thing about ROS is that it lets individual tasks work like individually, but at the same time cooperatively. So if we say that you have a group of people working together in a task, so these people get to work on their individual tasks and at the same time handle the communication between one another. And this is what ROS does, the power of teamwork. So we're going to talk about, a special type of node called a publisher and another type called a subscriber. So it pretty much works the same way YouTube does. I mean, let's just say there's this insanely famous YouTuber that you won't subscribe to, or to his channel, for example. So this content creator is the one that publishes content or messages or videos, and then you get to subscribe to that channel, or in this case, topic. And this topic is going to include all the new messages, or all the new videos coming from that content creator for you to view. And this is pretty much how publishers and subscribers work. They are just, some task executors that execute their own codes, but at the same time, they rely on information coming from one another. So a publisher publishes information that a subscriber grabs, and it helps it perform its task, which probably depends on this piece of information it gets from the publisher through the channel existing between them, which is the topic, and in case of YouTube, it's YouTube itself. So our agenda today is that we're going to talk about Python 3 install. So Python is a programming language. It has two main families, Python 2 and Python 3, but Python 2 is kind of outdated, so we're going to rely on Python 3 for our development, and we're going to install it in case it doesn't already exist on your machine. And then we're going to talk about our first ROS project. We're going to create our first ROS project and get introduced to the ROS utilities that we can use through the terminal. So it's going to be a pretty cool project, yet still basic. We're going to use the terminal to run our project and do a couple of other stuff, some other functionalities that are only available through the terminal. And this is where the power of the terminal will be obvious over traditional GUI methods. So let's dive in. So when it comes to installing Python 3, we're just going to use this link here, which is pretty cool and pretty straightforward. It's going to help you install Python in case it doesn't already exist on your machine. So here's the page. It contains the series of commands that you're going to type on your terminal. And as we said before, you would just open a terminal using Control-Alt-T. So you're going to just run a series of commands. You'll find a lot of options. We'll just stick to option number 1, which is using apt. So first of all, we're going to check the Python version installed. So let's just type here this command. And yeah, my Python is already 3. It's Python 3.8. So as long as it contains 3 at the beginning, so it's Python 3. I'm not really sure whether Python 3 comes built in the Ubuntu 2020 version, but you might want to check both the Python 2 and Python 3 versions on your laptop or PC. So if you want to check each individual version of its own, so I'll just type Python 2 version, and that will just display the version of Python 2 on my machine. What's the difference between Python 2 and Python? If I just type Python version, then it just displays the default Python that's being currently used on my machine, right? So you just have to pick like a default Python version, but it doesn't mean that only a singular version exists. My PC has both Python 2 and Python 3. But Python 3 just happens to be the default version, so when I just type Python, it will display the default Python version. When I type Python 2, it will display the Python 2 version on my PC, even though it's not the default Python language or the Python source. So I'm going to just click that, and it's Python 2.7.18. There's also Python 3 version, which displays the particular Python 3 version, even if Python 3 doesn't happen to be the default version of your machine. So I have both Python 2 and Python 3, so I'm good to go. In case you don't have Python 3, in case you run this Python 3 version command and it doesn't display anything, so you'll need to install the Python 3 using apt. So you'll just, copy commands as we did before. You can just click on here. This icon lets you copy the entire command if you want, instead of just selecting it first. And then you get to install some supporting software like this one, and some dependency or some repo called .snakes PPA. It doesn't really matter what this is, it just helps with the installation, nothing more. So you'll go through these commands as we did before. Then finally you'll install Python 3. Here this will prompt you to install Python 3.8, which is already present on my machine, so I'm not going to do that. And then finally, after you finish the installation, you can check whether Python 3 version is available. So I'm just gonna, sorry, not this one. I'm gonna check Python 3 version again after my installation. It's already present here, but I'm talking about your own PC. So after the installation, you'll check if the Python 3 version exists now and it says something like Python 3.8 point something, then you're good to go. In this part of our tutorial, we're supposed to learn about the utilities of ROS and how to create my environment and how maybe to create a simple project that allows me to see the utilities that we've just explained. So what I'm going to do first is I'm going to create a workspace. So what is meant by a workspace? A workspace is practically, the storage area in which I place my projects and my stuff. So it's pretty much, my building environment, or my, there are many ways to define this. So basically the workspace is the basic folder in which you store your projects and your codes. And this is a pretty broad definition. So let's go and create one and see how it looks like. So first of all, I'm going to click this icon, and when I click this icon, I'll find that I'm in my home directory by default. So what I'm going to do is I want to create a new workspace in my home directory. So as we said before, I like to use the terminal for this sort of stuff. So I'm just going to click Ctrl-Alt-T and then I'm going to use the make directory command in order to create a new folder for my workspace. So I'm going to call it Catkin workspace. And this name is not, obligatory by any means. It's just a conventional name that all programmers use. You can call it whatever. I'll just go and use the convention for this name, and I'm going to create my directory. So here's my folder, and I'm going to navigate to it using the GUI. But as we said before, we like to use the terminal for everything, so I have to navigate using the terminal as well. So I'm going to use the change directory command in order to get to my Catkin workspace. So I changed my directory, and as we can see, the address here is displayed as we explained before. And what I need to do now is to let the operating system understand that I need to make this folder a workspace for my ROS applications. So first of all, I need to initialize this workspace. And this is done by a command called catkin init. So I'm going to type catkin and then init. Init is short for initialize. And let's see what happens. So he displayed a warning or an error here that a source file or SRC does not exist. What is a source file? A source file is basically the file where your projects are stored inside the workspace. So I can't initialize this workspace unless you have such a folder. So I have to first make a directory called source in order for this workspace to be valid. So that's what I did, and I'm going to use the upper arrow in order to bring up the command that didn't work the first time, and let's see if I run it again, what would happen. Yep, workspace configuration appears valid. So basically the terminal is telling me that you have what you need to create a workspace, so you can go on. So if I press Control H here, we said that Control H lets you see the hidden components or the hidden folders in your directory. So indeed we have a hidden folder called Catkin Tools, and this means that the Catkin initialization was successful. And by the way, don't ask me what Catkin is, it's just a name. It's a weird name, I know, but just use it. Right. And by the way, the Catkin workspace is called that because we usually use the Catkin build tools to build it, so that's why it's we use this name by reference. As I said, it's not obligatory. You can call it whatever, but we'll just use the convention here. So after we found the hidden files and we know that our Catkin workspace seems valid right now, what we need to do is to build this workspace. So the first operation was to initialize the workspace. Now we need to build it, and by building we mean, it's like you're just constructing a new building. So first of all, you have to buy the land, all right, which is the directory in which we are gonna put our projects in, and you need to sign some legal documents, which could be referring to the initialization of this workspace, and then we need to build the actual building process before getting our projects into this workspace or into this building of ours. So what we need to do now is to build this workspace, and this is simply done through a command called, guess what, Catkin build. So I'm gonna type Catkin build, and then we'll see what happens. So he says that all one package has succeeded. What does that mean? And we noticed also that there are a couple of files or folders that popped up. So this is the SRC file, and this is our file of interest because we, place our projects and our codes here. But what are the rest of these files? Well, basically, as we said before, a Catkin workspace or a building has to have some legal documents, and these legal documents describe what's going on in here and are these operations authorized by the operating system or not. So the build file contains build information for your packages. That means when you write a new code, you have to build it, and people who have engaged in programming activities before know that a build operation means to convert your code from the English-like language in which it's written to a binary language or a machine language, which is basically made up of ones and zeros that the computer can understand. And we have the devil and logs. Logs usually refer to some, reports made on your operations or your code execution. So the logs pretty much contain, some records or whatever you call it. You'll find here that, the Catkin tools pre-build. So you'll find a couple of logs here that describe what happened so far. And we have the devel file. Well, the devel file is like, it's short for development, and it is really necessary for you to run your nodes, run your codes. The terminal has to know which codes you want to run, and when you reference a code and when you type its name, the terminal has to be aware of, this setup or this the workspace in which all of this is located. So pretty much you can find a solid definition for these three folders, but I pretty much gave you the intuition about them, and you don't have to worry about them because they're automatically generated and you don't have to do anything regarding them. What we need to do is all concerned with the SRC file or folder. So after the Catkin build, we'll go and create our package. So we had two terms here, the workspace, which is considered to be the big building or the big institution in which we place our projects. Our projects themselves may be referred to as packages. So when you develop a software package, you're just developing a certain ROS application for a certain situation inside this big building or inside this workspace. So what we need to do is to create a package, which is our first ROS application, which is going to be very simple. So we'll go to the SRC file, because the SRC file is considered as, the warehouse in which we place our projects. And we're going to need to create a new package. So how do we do that? First of all, I have to open a new terminal from within the SRC file. So there's a quick trick here that we can use. We can use the option. We can just have a quick right click, and then we select Open in Terminal. So what does that do? It just, it opens a terminal, but the address here is the same address as the folder we are in the visual or the GUI representation of the operating system. So it's pretty much easier than opening just a new terminal, which is located at home, and then changing the directory a couple of times to get here. We can get here right away, and this is pretty quick. So what we need to do now is to create our new package. So you can guess what command we're going to use, because it's pretty straightforward. I'm going to use a command called Catkin create package, which is pretty straightforward. So I'm going to just Catkin create and then package, and then the name of the package. We talked about publishers and subscribers earlier, so let's create some publisher and subscriber nodes. All right. So I'm going to call this package pub_sub, which means publisher subscriber, which is a name that suits our application. So I'm going to do that, and I'm going to click enter. All right. So it created the file, and it said that it successfully created the file. Right, when we get to pub_sub itself, we'll find two folders or two files here. They're files, not folders. There is a package XML, and there is CMake list.txt. You don't have to worry about what these do. Well, you just have to see them. If they are there, then we're all set. We don't have to worry about their functions, because, as I said, they are automatically generated, and they're the main function of any of these files is just to have a record of whatever you're doing and have some documentation for it. It is necessary for communication with the terminal and the operating system and stuff. What we need to worry about is our application itself. So we successfully created our Catkin package, or let's just say package, and then we need to, write some code. How are we going to do it? So first of all, I'm going to get to my pub_sub application here, or package. Let's call it package. And I need to, create some directory called scripts. So what I mean by creating a scripts folder, a script refers to, a script of your code. It's simply the code you write. And this is the most important thing in this workspace, because this is the file, or this is the folder that you have to create yourself, and the codes are totally yours. They are your domain. So you have to be absolutely focused when you're writing your code. So first of all, I'm going to create a new folder here. So I'm going to use the same trick as before. I'm going to open a terminal from within the directory itself, and I'm going to type a new command. So I need here to, no, actually it's not a new command, it's just make directory command. All right. And I'm going to, create a directory called scripts. So it's a really simple directory. And by the way, it's not obligatory to create this one. When it comes to the package and the workspace, there are sets of rules that you have to follow in order to create them, but the scripts is not an obligatory folder. But when you navigate through GitHub, or when you download some code, you'll find that most programmers use a convention in storing their files. So whenever there's a script, whenever there's a code you need to write, you have to include it inside some scripts folder. And it's not a must, but it's good. It's good practice to do that. So let's just stick to that. what I'm gonna do now is, well, I created my scripts. I need to, well, write my codes. So I'm gonna use the same. Alright, I opened too many terminals, so let's just stick to this one. Alright, I'm gonna change the directory only once, and I'm gonna get to the scripts folder. Yep, I'm inside my scripts folder. So now I need to create my code. Here we're gonna use Python, as we said before, because Python is, well, it is the optimal language for a ROS beginner. It's pretty much straightforward, and there are a lot of commands that could, there are a lot of shortcut commands that are not available in other languages, so we're gonna use it for now. And I need to create a .py file. What is a .py file? .py is a Python extension mainly, so I'm just saying that I'm creating a file or a script in which I'm intending to write a code in Python. So how to do that? When it comes to creating a file, and this is different from creating a folder is basically a directory, but a file is, a file. So we use a command called touch, and don't ask me why is it called touch, because I don't know. Alright, so I'm gonna say touch, and I'm gonna name my file. So let's just say I'll start with the publisher node. So I'm just gonna say publisher, and don't forget the extension, because we always do that. I myself do that a lot. And it's wrong, because if I just said touch publisher, then it's going to create a simple text file, and this is not, it's not Python, it's just plain text. So I have to indicate that it has a Python extension. I'm going to delete that. I'm going to write it. I'm going to get it right this time, so I'm going to say touch publisher.py. And here we are. We have a .py extension file now. So what I'm gonna do now is, before we write the publisher.py, we said we wanted a publisher and subscriber, so let's create a subscriber as well before just closing this. So subscriber. Right, we have two .py files, which are supposed to be, the code files for our project. So one thing you have to keep in mind is that these .py files are not executables by default, and what I mean by executable file, it means that it is a file that I could run. It's a code that I could run, and this is really something bad in Ubuntu. I don't know why, because whenever I create an extension like that, I'm gonna probably use it. I'm gonna probably run it, but you have to indicate that you have to run it, and this is pretty stupid, to be honest, but I have to do it anyway. So I'm gonna get to the properties here through a right click on the file, and I'm gonna go to the permissions, and I have to allow executing this file as a program, which is pretty obvious, but I don't know. I just have to do that. Maybe it's a feature related to security or something. I'm not really sure of that, but I'll just allow executing the file as a program, and that's it. All right. So we made them executables, and let's write our first code here. So let's just agree to a couple of stuff. Maybe you have some previous programming language with C or C++ or Java or whatever. Let's just say that, Python has its own distinct rules, which might seem a little bit different, but at the same time, there are a lot of similar features. So first of all, I need to indicate which Python am I using. I have to refer to the Python version I have. I have to tell the operating system that when you run this code, I'm using a specific Python version. So what I'm going to do first is that I'm going to type a command here, which includes hash, an exclamation mark, slash, user, bin, environment, or env, and Python 3, because I'm going to use Python 3. Alright, you can use Python as well, it's totally up to you, but I use Python 3. Alright, so what I did here is that, as I said, I'm telling the operating system that I'm going to use Python 3. So I'm adding the directory in which Python 3 files are stored in order for you to, see the libraries I'm going to use, because Python, obviously my libraries are contained within the Python 3 environment. So when I need to import some library or some, yeah, let's call it library. When I need to import some library, I have to indicate in which version it is stored. So since I'm going to use Python 3, then the operating system has to understand that it has to import this library from the Python 3 directory. So, all right, let's move on. I have to import libraries as I said, and when it comes to ROS and when it comes to using Python, therefore I have to import ROSPy. So what is this library? As the name suggests, it's a blend of ROS and Python. So I'm just saying that I'm gonna run ROS through a Python code. And this is pretty much it. So, well, I also need to, indicate what this code is doing. So what this code is going to do is that it's going to publish something. So since I'm publishing something, there is some sort of a message, and I have to determine what this message looks like. What is its type? So, for example, am I publishing integers? Am I publishing characters or strings or whatever? So I have to understand what data types is ROS capable of publishing. And this is, and we can, let's just get to the directory in which all of this is explained. So if we go to the other locations here and we get to our computer, we have run through this before when we got to the opt file and we were getting to a ROS version here and Neotic. We did that before, if you remember. So we had to go to the bin last time. I'm not really sure. All right, anyway, we'll go to share folder this time because obviously share has something to do with messages and sharing stuff. So we'll find here that there's a folder called standard messages. That has to be yes, standard messages. Here it is. So what this folder contains is all the standard forms of messaging that ROS has. So when we get here, we'll find there's a lot of data types. So we have byte, we have bool, we have character, and for those who are not really familiar with programming, all of these are just data types. So a character obviously refers to some character like A, B, C, and stuff like that. A byte is just, an 8-bit piece of data. We have floats, we have integers. So integers are just, like the mathematical definition. It's just an integer, and float is like a decimal number. It's not like an integer. It's you can, for example, type 3.41 for example if you want, but in integers you have to indicate that it's only 3 or 4. So, and you can find a number attached to the data type, for example, float 32, float 64, and this number has to do with the size of the data itself. So how many bits are allowed for this data type. So obviously when you use float 64, you can send larger numbers than float 32, for example, and you can find that there is a float 32.message and a float 32.multi-array, for example, or float 32 multi-array.message. So an array is like, a sequence of numbers, not just one number. So float 32 is if you want to send one number alone, and float 32 multi-array, that means you have to send multiple floats as a sequence. Well, there are a lot of data types, so let's just pick integer 64 or int64 here. Where is it? Oh, here it is. So we'll just pick int64 here. So if we open it, we'll find that it's very straightforward. I'm just int64 data, and this data is the variable itself. So I'm just defining some number here, which is my variable, and I'm indicating that is of the type integer 64. That means it's it's a 64-bit data or a 64-bit variable. That means it is a number that can be contained within 64 bits or binary digits. and that's pretty much it. So I need to send a message of that type. So what I'm gonna do is I need to import that data type from the standard messages directory. So I'm gonna type it really straightforward. So I'm gonna just say from standard messages .message. I'm going to import int 64. So, you know, programming is really easy. It's basically some twisted English in a sense. So these are the libraries, or these are the dependencies that I need to import right now. So what to do next? So first of all, in my code, or second of all, because we're in the second stage obviously, I need to initialize this node. So it really makes sense that whenever we create something new, we need to initialize it first. So you have to create a workspace, you have to initialize it. You have to create a publisher, you have to initialize it as well. So let's initialize this node. As we said, a node can be a publisher or a subscriber or whatever. There are other types as well. So I need to first initialize this node to, well, I need to say it's a node first of all. So I'm gonna write this command, which is rospy.init node. And we need to notice something here, that we use some function related to rospy. So I'm just gonna, you know, this import was really necessary for me to execute this step. And we have some arguments that we have to pass here. It's actually one argument, which is the name of the node itself. So I'm gonna just say it's a publisher node. Yep, and that's it. I know that many of you who may be used to C or C++, you know, are used to writing a semicolon at the end, but we don't do that in Python, right? We just stick to this format. And then after I initialize this node, I need to indicate that I have to have a publisher inside this node. So what I'm going to do is I'm going to create a publisher object. And what an object means, it's, you know, it's some kind of variable maybe that, you know, has a publishing capability. And let's just keep it at that for now. So I'm going to create an object called pub, because, you know, a variable usually refers to some numerical value stored in some space on my computer, but an object is like a handle, or like some, you know, it's just an object. I can't really describe it further. Let's call it just object, and let's just say an object usually has some features that extend beyond that of a simple variable. It might have numbers included, it might have even functions included, it might have some functionalities, so it's like an all-in-one variable. So we'll call it just an object. Alright, and I'm gonna say I have to use rospy again, but this time I have to indicate that this node has a publisher. And sorry, this publisher, this one has to be capital, and from this we can deduce that Python is case sensitive. So we have to write everything properly. So I'm gonna, well, it has 3 arguments first of all. What are the 3 arguments? First, I have to name the topic. So we said that the topic is like the channel that receives the messages from publishers and passes them on to subscribers. So a publisher just releases a message, puts or throws it in the topic, and then a subscriber could retrieve this message from this topic. So it's basically the channel, and I need to create this channel using my programming skills right now. So I'm going to call it topic. You can call it whatever. It's just, I'm calling it topic because this is a tutorial, so I have to keep names, you know, relevant as much as possible. Then the second argument, you have to determine what is the type of this message that you're going to use. So obviously I'm going to use int64 as I indicated before. So this is where this import comes handy, because I said before, or I defined that data type that I'm going to use. So I imported it already from the standard messages directory. So now the compiler knows what int64 means, because a compiler doesn't know anything unless I import the library or the file that includes information about this data type or this variable or this function or whatever. It has to be referenced. So whenever I'm using some third-party code, it has to be referenced inside my own code. Right? So the third argument is the queue size, and this is basically, it's like a buffer. Well, this topic thing is like a buffer. This channel has like a queue in which data or messages are thrown one after another. So if the queue is full, then I have to, get rid of the oldest message in order to provide some space for the newest message. So it's basically, if you can imagine some sort of queue in which messages are people and people are standing in line, and the queue is limited to a certain number. So in order to get new people to get into that line, you have to, let someone else pass in the beginning of the line. So that's pretty much it. And you have to determine what size that queue is. So I'm gonna type queue size, and you have to write it that way. So I'm gonna just, make it 1, because I'm gonna send really one message at a time. So I need each message to replace the old message, because I need the queue just to include the message that I'm interested in currently, which is the newest message, right? And that's pretty much it. Let's just have a comment here. And what a comment means, if you're new to programming, is that part of the code which is not an executable. That when the compiler sees it, it just ignores it. It is just there for the sake of readability and, providing some hidden messages for my collaborators or my colleagues at work to explain the functionality of the code that I've just written. So what I'm gonna do is I'm gonna first include a hash, and what a hash does is that it indicates that this line is not to be executed. It's just there for the sake of documentation, nothing more. So I'm gonna type here, for example, code or node initialization. Not just node initialization, it's also topic initialization. So let's just say node plus topic initialization. All right. So that's pretty much it for that part. Now we need to write the rest of the executable. So what am I going to publish? What is the data? I obviously elaborated on the data type, and I created the node, I specified its name, but what is the data I'm going to send? So I have to send something, and I have to send it repeatedly. That means I have to repeat and repeat and repeat and keep sending it, because nobody builds an application who just sends one message and that's it. It doesn't make sense. So we have to send something repeatedly. So once you have to send something repeatedly, you have to use a loop. And in this particular situation, I'm going to use the while loop. So the while loop is, it's that part of the code which keeps looping and keeps repeating itself. It keeps just executing the piece of code inside it over and over again until a certain condition is met. So I'm just going to type while, right? So what is the condition that I'm going to meet in order to stop executing this code or to break from it or break free? So I have to execute it as long as ROS is functional or ROS is working, all right? So unless the user terminates ROS, this part of the code keep executing indefinitely. So what I'm gonna do is while not, which obviously is the opposite of while, ROSpy dot is shut down. Yep. So what does that mean? It means while not ROSpy or while not ROS, is shut down. So if I'm not shutting it down, then this part of the code will keep executing. And this command is pretty standard, so I have to type it as is. So when I happen to write a while loop, I have to indicate that this part of the code following the while statement is special. It's a property of the while loop. Nobody else has to access it. All right. So when I press enter, first of all, I have to include, like these, this small symbol here. I can't remember its name actually. It's pretty embarrassing. Anyway, so I'm just have to include that to indicate that the rest of the code is just a property of this while loop thing. And I have also to provide some sort of indentation. So what does that mean is that this is the, the higher level hierarchy of the code. All right. So when I'm writing a special part, a part that is a special property of this one, it has to be, in a different part of the hierarchy. So when it comes to C++, you just, place semicolons here and there. Here in Python it's different. You have to provide something called indentation, and by that I'm just gonna, leave two spaces here. Some people leave tabs. All right, so I'm gonna get back here and use a tab. Where's the tab on my keyboard? This is a new keyboard, so I'm not used to it yet. Yeah, here it is. So you can, use a tab or use space. Personally, I use two spaces, right? This is what's meant by indentation. You have to just separate, this vertical boundaries here. If there are imaginary vertical boundaries here, you could imagine that this part of the code is like spaced a little bit to the right. So I need now to publish some data. So I'm going to publish number 1, for example, right? So I'm going to call my object, which is pub, the object I've just created, and I'm going to say .publish. And what .publish means, it's a function. Function has some functionality that it implements, and in this case, publish obviously means that I'm publishing data or publishing some number, So I'm going to use, or I'm going to write 1. So it's a numerical value, that's it. All right, so I'm publishing 1, that's cool. So what are you going to do next? If I just keep it like that, when it comes to running a code, your processor is really, really fast. And when it comes to a code like this, it's pretty basic, so it's going to run really, really fast, and it's going to print, ones really fast, and we don't want that because the terminal will just explode with ones. So I'm gonna, have some sort of delay between each cycle of execution. For example, a 1 second delay, in order to, slow things down a bit. So I'm gonna use ROSpy, which is another function of the ROSpy library here. I imported, and it's called sleep. So I'm just, commanding my my code or my executor to just sleep for a while, and I'm gonna type 1 because the unit of the number you're supplying here is seconds by default, so I'm just saying that you have to sleep for a second before continuing your cycle. So that's pretty much it. I believe we're done here. Yeah, we can just write a comment here. Just say that this is the looping, right? So I'm gonna hit Control Save in order to save my file. All right. I think we are done here. Yeah. Let's get back to where we were. I think we were in the home. Yeah, we were in the home directory, and we were in the Catkin workspace, and then the src, and then inside our package, and inside the scripts folder. I know that's that's a lot of directories, but you get used to it. All right. So we created our publisher. What we need to do now is to maybe run this publisher. All right, let's see what happens when we run our publisher. So let's just use one of these terminals, or close some of them. Maybe close these two and just keep this one. Yeah. Right. By the way, when you need to run a ROS application, you don't have to be inside the Catkin workspace or inside your home directory or whatever. You can just be in any directory you want. So I'm just gonna, I'm included here in the Catkin workspace, no problem. So in order to run a ROS application, I have to run the master. And when we say master, we're saying the mastermind behind running my application, and that's called the ROS core, which is like the kernel of the ROS operating or the robot operating system I'm using. So it's like the master that organizes everything. So it has to run first before I attempt to run any code of my own. So I'm just gonna hit enter. So yeah, it started the core service and now I'm good to go. So I'm gonna open a new tab, and well, but what I mean by a new tab is that I'm gonna be in the same terminal here, but this terminal might have several tabs. So I'm gonna click Control Shift and T. So I'm included within the same terminal, but I have moved to a new tab. So what I need to do now is to run my Python file here, or in this instance it's not just a Python file, it's a node, and there's a difference between the two because running a Python file is pretty standard, but here I'm running the Python file as a ROS node, so it has some specific instruction in order to do that. So what I'm gonna do is I'm gonna type ROS run, and the name of the package. I have to indicate which package I'm using. All right. So I'm using Catkin, I'm using PubSub. This is the package, not the workspace. And I need to indicate which node do I need to run, which is publisher.py. So ROS run, name of the package, and then my Python file. I'm gonna hit run. But it displayed an error. PubSub cannot be found. What happened? So first of all, I have to close this, and if you want to kill any ROS process, including the ROS core, you have just to click Control and C, right? That kills it. So first of all, I didn't build a Catkin workspace after I created my new publish on subscribers. All right. So why do I need to build it again? Because you created a new package, and whenever you create a new package, you have to build the entire workspace. I know it doesn't make sense because if you create a new package, you have to build that package. You don't have to build the entire workspace, but this is how ROS works. This is the standard way of doing it. And I don't know why it was made that way, but we have to, follow the rules. So I'm gonna open a new terminal from within the Catkin workspace, because in order to build the Catkin workspace, I have to be inside the Catkin workspace. So I'm gonna say Catkin build, right? So, yep, my package was successfully built. That's pretty good. All right. So the second mistake I made was that, well, my terminal doesn't know the Catkin workspace. It just doesn't know it. Well, it is included in the Catkin workspace terminal, but it doesn't know how the Catkin workspace works. So I have to source it. And if you remember last time when we installed ROS, we said that the terminal has to be familiar with ROS through sourcing, and we did source the ROS file. There was a specific command that we wrote which has to do with sourcing, in which I'm sourcing the ROS setup. And if you remember, if we got back to the home workspace here, there was a hidden file which is called bashrc. If I got it here, if you remember, that line was typed right after the sourcing command was typed into the terminal, which means I need to source my ROS version in order for my terminal to understand how ROS works. For example, when I say ROS core, the terminal has to understand what ROS core is, and this is what this sourcing command does. The same thing goes for a workspace. my terminal has to be familiar with that workspace first and how it works. And if you remember, let's get back to the Catkin workspace here. First, let's hide the hidden files, and then we get here. We had a devel file here, a development file, and this is one of the functions of the devel file. It has something called a setup.bash file, and this setup.bash file lets the terminal understand the exact functionality of this Catkin workspace. So in order to get familiar with the Catkin workspace, so I could understand that you need to run some node from the Catkin workspace and stuff like that. The terminal is not human. It doesn't just understand everything by intuition. It's programming. So you have to include the exact setup that lets the terminal understand what the Catkin workspace is, and therefore be able to comprehend your commands and comprehend your codes. So I need to source that as well. And how to do that? First, I have to close this terminal and open a new one. So I'm just, open a new one from here, right? And in that terminal, I have to do my sourcing. So how do you do that? I'll have to type source, right? And what are you going to source? I have to source the setup.bash file in the devel folder or the development folder. So I have to type the exact address of that file. So it's home, then Catkin workspace, then where was it in the Catkin workspace? We know that there is a devel file, so devel folder, here it is, and then the setup.bash. Setup.bash. All right, there we go. And we also need to open the new tab as well, and we have to source the same thing, because I can't really remember whether you need to do it within the same terminal. Just to be safe, I think when you open a new terminal, you have to source. But when you open a new tab, I don't know if the same terminal command works across all tabs, but just to be safe, I'll just source it in the new tab as well. So let's just copy that and let's paste it here, right? So we sourced our file. So let's just run the ROS core first. Yep, here it is. And let's just try to ROS run our code again. Yeah, here it is. And voila, it's working. Well, it might seem a little bit funny because nothing really appeared, but this in ROS, when you type the ROS run command and then you find that your that white thing moved here, that means that the node is working. So we need proof that the node is working. You just don't trust me, and it's okay. I'm okay with that because it's my first tutorial and stuff. So let's just search for that topic. Let's search for the node, right? So there's a command. There's a nice command that is called list, and we talked about list before in the list folders in your directory, but here we're going to use a special type of list that is related to topics or ROS topics. It's called ROS topic list. So I'm going to type ROS topic and then list. So as you can see here, there are two ROS topics here that I have nothing to do with. They're just natural ROS topics. But here, guess what? This is the topic that we created in our code, which is the topic code. In case you forgot. Well, I haven't opened it yet, so no problem. All right. So this is the name of the topic that we've created. All right. You still don't trust me. All right. Let's just say we need to really make sure that the ones that we talked about before, the sequence of ones that have to be sent repeatedly every 1 second are currently being sent. So how to do that? There is another command which is called the echo command. So what I mean by echo is that like I'm some sort of a bat or something, I'm just echoing the environment in front of me in order to make sure that something exists, or a tree or something. I don't know. So let's just echo for that topic. I'm going to say ROS topic echo. All right. What is the name of the topic you want to echo? So it's the same name, /topic. So, by the way, when you write a topic name, I know that the original name was topic, but in ROS you have to type /topic in order for that topic to be, understood. So I'm going to do that. Let's just see. Here it is. Data is being sent and it is a 1, right? So this is what the ROS topic echo does. It just navigates and gets to the topic and then, unveils the queue and just, shows the data inside my topic. All right. So whenever I'm sending something to this topic, it should be, typed here. All right. So I'm gonna press Control C just to kill this ROS topic command, and I'm gonna, do the same here to kill this publisher.py, and I'm gonna kill the ROS score. All right. So let's just say I happen to close this terminal and I need to open a new one, so I'm gonna just say Control-Alt-T. This is a brand new terminal. So I'm gonna say ROS core again, right? And then Control-Shift-T in order to open a new tab. Then I'm gonna, ROS run sub publisher.py again, and it's not found. What happened? As you can see, I didn't source my Catkin workspace, all right? And this is why the new terminal doesn't understand. What do you mean by pub sub publisher.py? This package, I cannot see this package. You have to source its setup in order for me to be able to see it and run it. So it gets really boring when you have to source the same thing over and over again, especially when you're working on such a big project and you have, type source and source and source and source. That's pretty boring. So we need an alternative. So our alternative here is to get to the source code of the terminal, which is, as we know, the hidden file known as bashrc. So when you get to the bashrc in the end, you can type the sourcing command at the end of the bashrc, the same way we did with ROS. As you can see here, ROS is being sourced every time you open a terminal. This is why the terminal is automatically, aware of what ROS is and how to operate it. So we need to do the same thing for our workspace. And in fact, I did it before for some workspace here. Yeah, this is an old workspace that I used to have. So let's just remove the comment and let's just change this and let it be Catkin workspace. I'm gonna type Catkin, right? Yep. So instead of just, typing this command in my terminal, it will automatically be loaded once the terminal is opened. So I'm just going to set Control-H and let's just, open a new terminal. By the way, you can open a new terminal by just clicking that icon here. So I'm going to do the same thing. I'm going to, type ROS core. Then I'm going to open a new terminal here. Not a new terminal, a new tab, sorry. So I'm gonna ROS run sub publisher.py. Let's just press enter, and here it is. The terminal now knows what publisher.py is. It can see it thanks to my sourcing command, which has been included in the bashrc file. So I saved myself the effort and the boredom. All right. So let's move on to the next part, which is our subscriber. So we said that we need to create a publisher and a subscriber. Now we managed to create the publisher. Let's see about the subscriber. So I'm gonna press Control-C here, and Control-C here. Sorry, Control-C, not C. I may close that as well. Let's get back to our Catkin workspace and then the src, which includes, which is the warehouse of my projects. And here's my package or my project. All right. We need to get used to ROS terminology here, so let's just stick to package, and then I'm gonna go to the scripts, which are basically the pieces of code that I'm responsible for in this big building. So I'm just gonna open subscriber.py, and I need to include some code here. So what subscriber does is that it's supposed to receive this message from the publisher. So how to do that? First of all, there are some stuff that are common among the two codes, and pretty much every code I'm going to write in Python, I have to reference the Python version I'm using. So I'm going to use # !// user bin environment, and this is the directory in which Python 3 is located, and then I'm going to type Python 3. All right. Then I'm going to import ROSPy because I'm obviously using ROS and I'm obviously using Python, so it's ROS Python, ROSPy. And I need to import the specific type of message that I need because, well, I'm going to receive a message of the same type as publisher, so I have to, be familiar with this type of messages, which is N64 or integer 64. So I have to import the same type of message from standard messages dot message. I'm gonna import int or integer 64, right? So far everything seems to be, the same. Well, speaking of the same, we also have a node here. It is a subscriber, but still a node, so we have to initialize this node first. So we have to type rospy.init node, same as before. And we're gonna type here subscriber. I'm gonna call subscriber. You can call whatever, but it's obviously a subscriber, so I'm just gonna call a subscriber. Well, so far I've indicated that the name is subscriber, but I need to really indicate that this is subscriber using some programming. All right. So last time we created a publisher object for the publisher. We need to do the same thing here, except that we don't really need to define an object. We just say ROSPy to subscriber. The last time we typed like something like pub equals ROSPy to publisher and stuff like that. No, here we just say ROSPy to subscriber. We don't need to create some object. So subscriber here. Yep. And we have 3 arguments as well, but there's a bit of a difference here. So the first argument has to be the name of the topic to which I'm subscribing, and it has to be the same exact name I use for the publisher. Otherwise, I'm going to subscribe to a topic that doesn't even exist. So I'm going to type here topic. Yep. And the second argument is the data type, right? So I know that I'm going to receive a message which is of the type int64, and then there's a third argument, and no, it's not the queue size, right? The queue size is just for the publisher object, or the publishing part. Here we have to define something called a callback, and the callback is some sort of function that is responsible for processing the message that I received. All right. And if you don't know what a function is a piece of code that I'll probably gonna use it several times. All right. So instead of just typing the same code over and over again, I'm just gonna keep that code referenced by a certain function. So that piece of code is pretty much similar to a while loop or a for loop or these sorts of loops, but it doesn't execute repeatedly. It only executes when I call it. All right. So this is what a function is. So I'm gonna call this function callback because it's called a callback function, by the way. But a callback function, well, you don't have to call it callback. I can call it, for example, Sam_callback or whatever. But we just call it callback because in order for the code to be readable, I have to let the person who's reading this code understand that this is a callback function and not a normal function, because there are normal functions and there are callback functions. Callback functions are like interrupt service routines. They're a special type of functions. So I have, despite the fact that I don't have to pick a specific name for them, but I need to indicate it's some sort of a callback function. It's a special type of function, right? So I'm just gonna call it callback. You're free to call it something like subcallback, subscriber callback, or not really, maybe topic callback. All right, as long as they're callback in the end, then conventionally speaking, you're okay with that. I'm just gonna call it callback because this is a tutorial, so it's not a special type of callback. It's just the only callback we have, so I'm just gonna call callback. By the way, you can have, like multiple subscribers within the same node, right? So you can have multiple subscribers to different topics within the same node, and this is why you might have to call callbacks different names. Like for example, Sam callback when you, for example, this is the callback for a topic called Sam, and another topic called, for example, distance. So you're gonna call it distance callback just to differentiate different callbacks, right? But here we have only one callback, so I'm just gonna call it callback, and that's it. So how to define this function? So in Python, defining a function is pretty straightforward. I'm gonna type def, which means define, and then the name of the function, which is callback, and then the arguments the function I'm gonna have. So here we have only a singular argument for this special type of function, which is the message I'm gonna receive. And you can call it whatever. I'm just gonna call it message, like MSG. You can call it, if there are multiple messages from different subscribers or different callbacks, you can call, for example, Sam message or Sam underscore message, distance underscore message, and stuff like that. So there's not a specific name you have to use, but it has to be readable, And as we agreed before, whenever I place this, this thing here, I can't remember its name. It's 2 points above one another. I'm gonna call it that. All right. I just have to indicate that whatever comes after is a special property of this function or loop or whatever. So I have to add spaces or some sort of indentation to indicate or to let the compiler understand that the code that follows this this part of the hierarchy is a property of this hierarchy. So yeah, that's pretty much it. So what I'm gonna do here is, what do you want to do with this message? Well, you can do different things. You can add to it, you can subtract from it, you can print it, for example. Let's just say I want to print it, right? I want to print it on the terminal. So I'm gonna use a command called print, and this is the beauty of Python. You just, you want something, you just typed it, and that's it. It's true. So I'm gonna print the message I'm gonna receive, and I'm gonna say print message. All right. So far so good, I believe. Let me check if I've got something. So we imported the libraries and we defined or initialized the node. It has a name, and we reference the topic to which I'm subscribing, and the data type, and the callback function. Oh yeah, I almost forgot. Well, a subscriber is supposed to run indefinitely till the ROS core is terminated. So I have to indicate that. I have to include in some sort of a ROS loop, which is a special type of loop designed for ROS. So I'm not gonna use a while loop because that's pretty mainstream. I'm just gonna use a special type of ROS functionality called the spinning functionality. So I'm gonna just type ROS dot spin, and what this does is just it lets the node, it keeps the node running till the ROS core is terminated. It's pretty much like the walnut ROS is shut down, but we use it for subscribers mainly. So it's ROS dot spin. All right. What is going to happen here, in order for you to understand the flow of this code, is that, first of all, let me just comment this node. Node plus subscriber initialization. All right, so we have it. And we have this, we'll call this callback function. And, the looping or the spinning, let's just call it spinning. All right, to understand the flow of this code here, we have, that part of the code which has to do with the initialization and the definition of the callback, and then we keep spinning. So that's the main part of the code, all right, and it executes only once. Once I got to the spinning part, I'm gonna get locked into this function. I'm just like looping inside this function indefinitely, as long as ROS is working. So how do I get to the callback function? I mean, I defined the callback function here. So as long as I'm logged up in here. So how am I gonna get to this function? Well, as I said before, this is not an ordinary function. It's a function that, it's like an interrupt service routine. It executes when some event happens, which, triggers the code to leave the ROS.spin and get to execute the function, then get back to the spinning once more. So when does a callback, do that? It does that whenever a new message is published to the topic. That means that I'm only going to execute this function whenever a new message is published to my topic, right? So which means that I'm going to print the value or the message once the message is received from the publisher. So the publisher is throwing something or is throwing some message to the queue of the topic, and once it throws that and the topic receives it, then by default I receive it as a subscriber and process it. And in this case, our processing here means printing the message as is on the terminal. So I think that's pretty much it with the subscriber. I'll leave it here in case I forgot something and I need to add it. Right. So let's open a new terminal. As I said before, we sourced our Catkin workspace here, so we don't need to source it again in the terminal. I'm just gonna type ROS core, and then I'm gonna open a new tab in which I'm gonna say ROS run. ROS run. We're gonna get the publisher to work first, so I'm gonna say you have to indicate the package name, which is pubsub, and then publisher .py, and we click enter. Alright, then I'm gonna open a new tab, some new tab here, which is gonna run the subscribers. So I'm gonna use the same exact command, except that, well, the only thing that is different is the name of the Python module itself. So I'm gonna type subscriber here, subscriber.py. Right, here we go. The data is being printed indeed, so that means that indeed the publisher is publishing something to the topic, and the subscriber is receiving that data from the topic and displaying it because I made the callback function print this data here. So what happens if I kill the publisher? I kill the publisher. What happened here? The data stopped flowing because the publisher is not, creating some new data and passing it over to the topic. So the subscriber has nothing really to show. The callback function is never called anymore. That's pretty much it. That's pretty much the explanation of what's going on. And we can see that this is a powerful tool because I can let different nodes work in parallel. So I'm executing all my stuff. I'm just waiting for new updates from other nodes. So we're working cooperatively on the project instead of just writing some sequential code which waits for some lines to be executed and then the following lines and then the following lines. It's not really efficient. So this is the beauty of ROS, right? I'm gonna kill the core here. So what we're gonna do now is, well, let's get introduced to some other commands, like let's just say I want to know if a certain package exists. So let's just say I copied some package content from another collaborator, and I need to know whether a specific package exists within this workspace. All right. So what we're going to do is we're going to type a command that really searches for specific, like packages. So we have ROSpack list here. So what it does, it basically lists all the packages that are located on my computer, right? So you can find a big load of packages. And in fact, I wish I could say that they were all mine, but most of them are really, you know, uh, property of the ROS installation I made. Not all of them are mine. So you can find opt-ROS. So whenever you find that opt-ROS thing, you are referring to the directory of ROS, or the main directory of ROS, which means that they're property of the ROS installation and not mine. So we can also find the ones that we've created. So let's just look for pubsub. We might find it somewhere here. It will be pretty hard to spot it. Well, it exists somewhere here. I don't know where exactly. I can't see it right now because there are a lot of things, but it exists there somewhere. So let's just say we want to make sure that it exists, and I don't have to go through all of these packages in order to locate it, because it's kind of blinding. So we have to use the same command, but we're going to focus on a specific package that we need to search for. So we're going to type ROS backlist and then the spacer here, and then I'm going to say grep, and I'm going to type the name of the package that I'm searching for. In this case, I'm searching for pubsub. Yep, here it is. So it displayed the exact address of this particular package that I'm looking for. So it's located in home. This is the name of my home, which is home Sammer. You can also type it like this in case you don't want to display the full name of your home directory, but that's the original name, right? We use tilde instead of that, but you can use that or tilde. It's the same thing, right? Then we have it located inside the Catkin workspace, and then the source, and then here it is, pops up. Yep. So that's how to find a specific package if you're looking for a specific package in a workspace, or even any workspace, because here you can find that we even displayed the packages that are located within the ROS main installation file or the opt file or folder. So this command just displays all the packages on your computer. All right. So let's just say I want to delete some package. All right. Let's just say I created a package, for example. Let's create a new package. Let's get to the Catkin workspace and the source. All right. So here we're located in the source here, and we need to just close I just close that. We're located in here, and I need to create a new package. So as we said before, we have to open that in the terminal and say that I want to create a new package. And as we said before, in order to do that, you have to use a command called catkin create package. So I'm going to use catkin create package, and I'm going to call it, package2, for example. Yep, and it is created, and you can find the CMake list file and the package XML file. So I'm not gonna include anything in it because it's just a test package, because we want to learn how to delete this package after I made it. So let's just say after you created the package, you'll just have to build the entire workspace because you created a new package. So I'll get here and I'll open this workspace in terminal, and I'll just say catkin build in order to build a new package. Along with the old one, it will be like built again, or we'll just find that it's already built, so just focus on the new package. As I said, it's not logical to build all the workspace just for the sake of one package, but it is what it is. All right. So I built a new package here. It still has no scripts or anything. It's just an empty package. So let's just say that this package was full of codes and full of scripts and stuff like that, but I need to delete it anyway. So in order to delete it, I have to do, I have to go through some steps. First of all, I need, just move to trash. Is that it? Well, that's not quite enough, because you have to delete it also from the build files and the development files that you have, because in these, if you go to the Catkin workspace here, there are other directories that have to do with your packages. So the logs, the development, and the build folders also include information about this package that still exists. Although you deleted the package itself or the content of the package itself from the source file, it is still there somewhere in these folders, and I need to clear it. All right, totally clear it from my workspace. So what I'm gonna do is I'm gonna use a command here. I'm gonna get to the Catkin workspace and I'm gonna open it in the terminal. I believe I did that before. Yeah, here it is. And I'm gonna type a specific command, which is called let me remember, Catkin, yeah, Catkin clean. So it's Catkin clean, and then I'm gonna clean. Of course, you won't just press enter. Just hold on, because you're gonna clean everything. I'm just gonna clean the orphans. Okay. This sounds pretty ruthless when you think of it as a command, but anyway, when I say clean orphans here, I mean that all this data that has no source file or has no source information located inside my source folder, I'll just have to clear them. Alright, so I'm going to use Catkin clean here. Alright, so yep, package 2. So he did spot the package 2 has no information inside my source file, and he cleaned it because he considered it as an orphan. Alright. Alright. So that's basically it when it comes to the ROS run, running ROS nodes and creating them, creating a package and creating a workspace. We also need to get introduced to a new concept called the launch. So what's the difference between running a ROS node and launching a ROS project? So assume that you have like 10 nodes, right? And you have to run each one of them, to make the project work. So you'll type 10 ROS run commands, which is, pretty boring. So we have another utility called launch. The launch allows you to ROS run many nodes simultaneously at the same time. You don't have to type an individual ROS run command for each node. So let's see how we do that. First of all, I'll get to the package. We created a folder for the scripts, and we're gonna create another folder for the launch files. We're gonna, we're gonna get to know what a launch file is, so you don't have to stress out. So let's just close all these terminals. Let's open a new one here, right? You have to open the terminal here because I'm going to create a folder inside this directory, so I have to be located within the directory itself. And I'm going to say make directory launch. Sorry, I typed that wrong. Launch, right? So here it is. We have a launch folder. Of course, it's empty in the beginning, so I have to create a new launch file. So launch is pretty much, similar to scripts, because in scripts we write .py files or Python files. In launch we also create such files, but they are not .py files. They have the extension .launch, right, to indicate that they are launch files, not Python scripts. They are also scripts, but they are launch scripts, right? And they are written in a language called XML. Not Python, but it's pretty easy, you'll see. So let's open a terminal and let's create this launch file. So as we said before, in order to create a file, we use touch. So touch, for example, let's call it start.launch. All right, so there it is, start.launch. Now I need to fill it. So XML is, a bit different from Python, but we don't have to get, to the details of XML. We just have to know specific commands, and that's it, not all the commands. So we need the part that is related to launching. So I'm gonna, type the following. Slash launch. So this is where my entire code is contained. It's contained between these two launch lines, all right? And they're, contained within something like an arrow, all right? So I'm just gonna, we have similar indentation practices here, so I have to keep 2 spaces between these two, I don't know, hierarchy levels. This one hierarchy level because they're in the same level. So I'm gonna shift to a new level here, so I have to provide some indentation, and I need to provide the node information because I'm gonna launch nodes, so I have to determine the information of each node in advance. So I'm gonna use these 2 arrows here, and I'm gonna say node first to determine that I'm running or launching a node currently. So I have to supply some information like the name of the node. So it's gonna be a variable here, and I'm gonna say that the name is equal to, for example, the first node is publisher.py. This is the name of the file. Sorry, the name of the node. So it's publisher node because we call the publisher node inside the Python file. So the name refers to the name of the node, and we've got the type. The type here refers to the name of the file itself, the name of the entire file, which has the Python extension. So I'm gonna say publisher.py, and we have to differentiate between the two because I myself get confused all the time between the two. Sometimes I get the name of the file here in the name section. The name section here is is for the name of the node, but the type is for the name of the file itself. All right. Then you're gonna specify the package. So this node is located within a package called pubsub, as we know. And the output, it basically says where they want the output to be displayed. Well, the obvious answer is the screen. So I'm gonna type screen here. Yep, and then backslash. Is that a backslash or a normal slash? Can't really tell the difference. I'm horrible with symbols and stuff like that. Anyway, we need to define the second node, which is the subscriber node, and it's pretty much the same order. We're just gonna copy that in order to save time, and I'm gonna change the arguments themselves or the names of the variables. So here, the other one was called subscriber node. Let's just check here. Yeah, we called it subscriber, just subscriber here. So let's just call subscriber node to make it more relevant. And I'm gonna save it, control save, and then we called it the same thing here, subscriber node. Subscriber node, yeah, type is equal to subscriber.py. This is the name of the file itself. And then we've got the name of the package, the same name as here, and the output is also the screen. All right, that's pretty much it. So it's pretty easy. You don't have to stress out about the XML file. You just have to memorize this specific line and just change the arguments. All right. So we're done with creating the launch file. So let's launch. So we have a terminal here. This terminal would do. You have another one here. Yeah, here it is. So let's type ROScore. And this time, instead of just running individual Python files or nodes, we can just launch the whole nodes using a single command. So we're gonna type, obviously if you use ROS run there, then you're gonna use something called ROSlaunch here. And you're gonna indicate the name of the package, which is pubsub. So ROSlaunch, pubsub, and the launch file, of course. So the launch file is called start.launch, as far as I remember. And then you're gonna launch. So you're gonna press enter, and you can see that indeed the output is being displayed on the terminal here. which is the output of the subscriber, because both the subscriber and the publisher are running simultaneously here. If you don't trust me and you want to check it out further, so let's open a new tab and let's list the nodes that are currently working. So we're gonna use ROS node list, which is, pretty much is like ROS topic list. It's the same thing. By the way, you can figure out a lot of commands on your own. You can write a command and you're not even sure if this is the right command. It turns out to be okay because you picked the most logical name. So ROS node list, yep, we have, well, the ROS out node. We have nothing to do with that. We just have to do with the publisher node and subscriber node. So the two nodes are currently working. And if you want to list the topics as well, you'll find, yeah, our topic is there, and you can even echo it. ROS topic echo. The name of the name of the topic. Yeah, it's there. It's definitely there. So we can kill the launch using Control-C as we're used to, and we can kill our score as well. Right? So that proves our theory. A launch file can indeed simultaneously run multiple nodes at the same time. So let's just get introduced to one last command here. Let's just say that we have, let's separate the ROS core. I shouldn't have closed it. So we launch the file again. Let's type a command here called RQT. So RQT is like a ROS visualization tool that lets you see the entire architecture of the currently active project, right? So it displays the architecture of the currently active project. So let's just hit enter. So what you're gonna do now in the RQT, you have plugins here, and I'm gonna get to the introspection plugin. So the introspection plugin lets you see what is happening right now in several aspects. So let's just say I want to draw a graph for the currently active nodes that displays the relationships between these nodes. So I'm gonna type introspection, and then I'm gonna get to the node graph. So as you can see right now, just really small. But let's just turn nothing, right? Let's just try to scale it. I don't have a mouse, so scaling is quite difficult when you have to do it with your touchpad. I think there was a zoom here, a zoom icon here somewhere. So let's just close this one as well. Right, so we close these, but I still can't figure out how to zoom in. Yep, yep. I need to just zoom in a little bit. We need to purchase some mouse here. Let's see. No, it just saves it. Alright, let's just save it. Save the image, which is, the equivalent image, or I'm exporting an image. Right. Where did I export it, by the way? I didn't look. Scripts, ROS, yeah, it's located within my package. So let's just view it in here. Pops up, yeah. So if you can see here, this is, the area that I wanted to zoom in to, maximize it. But I can't do it here because I don't have a mouse and my touchpad really sucks. So we have it here. So this graph, this introspection graph or the node graph, lets you see the relations between the nodes or the individual nodes. So we have a publisher node here and you have a subscriber node here. And here's the topic. The topic name is topic. So it just represents like a visual representation of what's going on, and it's pretty useful when you have a lot of nodes running, and especially if you're running a package that you didn't create yourself. So it lets you understand what are the relations between the nodes, who publishes what, and who subscribes to what, and it's pretty useful. And you can export images from. Alright, so I'm going to delete that because I don't need it. And I'm going to get back here. I'm just going to kill this RQT thing. I don't need it. And then I'm going to just kill the processes. So this part of a lesson is concluded now. So let's have a quick summary on what we did today. We defined a workspace, what it is, and how to create one. We said that it's like the big building in which your projects are contained. Then we used Catkin tools. It's not Catkin, it's Catkin. That's a typo. We use Catkin tools for building our projects. So these are the tools that we use to build that building we need to build in which our projects are contained. We also use it to initialize the contracts or the legal paperwork that we need to do through initializing our Catkin workspace, and then we build the Catkin workspace in order to be ready to include our projects inside that big building of ours, which contains a source file. And this source file is pretty important because it is like the warehouse in which our projects are installed, all our codes and build files and stuff like that, and our packages, of course. Then we learned how to create a package and how to include it within the source file of the Catkin workspace, and we said that whenever we create a new package we have to rebuild the entire Catkin workspace, and it's not really efficient, but it is what it is. Then we learned how to create simple publishers and subscribers, and we said that there are specific types of nodes that are responsible for delivering information to one another in order to execute their tasks. And we got introduced to some ROS terminal commands that allow us to run our nodes or launch our nodes, or list the topics that are currently active, or maybe visualize the entire process on our screen. We also learned how to delete a package and how to remove it or remove all its traces from the entire package. So we got pretty much involved in the process of creating a ROS project, and we now know the architecture of a ROS workspace. So in our upcoming tutorials we will focus on more projects, and we'll start to look into some cool applications for us to execute.